Bonjour and welcome to Wahsa Distance Education Center's Radio Zoom classes. This is MBF3C, grade 11 college math, and I'm Bronwyn Slate. In order to participate live, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or through the television at Bell Express View channel 972. You can always join me live through Zoom, and the link has been provided to you by me, your teacher, and also is available through your DEC. Our classes are scheduled from Monday through Thursday from 11 till 12 in the morning. And we are just wrapping up our second week of our 9-week course. A reminder of what work to submit for marking. The support questions that are in your booklet are the ones marked with the pencil icon, and they are not for marking, but you can decide which ones and how many of them you need to do depending on what your needs are. If you are understanding the concept, feel free to skip the questions. If you need more practice, let me know and I can send you more questions to practice. The answers are in the back of your booklet, so please check your work to make sure you're on the right track and that things are making sense. Though there have been some mistakes found, so if things are not lining up and making sense, please let me know and I can maybe find some corrections that need to be made. The key questions, the ones marked with a key icon, are the ones that are to be submitted for marking. So do all of those questions and show all of your work and all of your steps and thinking so that I can give you credit for all of your understanding and you don't lose marks because of small errors or a common mistake that you're making, but you're getting everything else right. So please show all of your work. Submit your work for marking. There are 3 methods. The first method is to scan and send your work in electronically. You can scan using a printer or scanner, but you can also use your smartphone if you have one. The iPhone Notes app has a scan function, and the Android Google Drive app has a scan capabilities. So you can use those. If you need help with that, let me know and I can walk you through it. Then you can send your files to through email to student@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger to bslatewahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We're the big red building next to the post office, and there is a small white mailbox at our side entrance that you can put your work in. Because we're currently working remotely, it may take a few days for me to get your work if you drop it off in person, but as soon as I get it, I will mark it as quickly as I can and return it to you. The third method is to hand your work into your DEC. Your DEC can then either express your work or fax it in to 807-737-1732 or toll free to 1-800-463-7852. Always, if you have any questions or concerns, you're struggling with anything, or you just need some confirmation about things, please do reach out and contact me. You can even just check in it with me on a daily or weekly basis if you need to just sort of stay on track. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca, or you can Facebook message with me at bslatewahsa. You can always call and leave a message for me at the office, and I can return your call. The number is 807-737-1488, or call toll free 1-800-667-3703. My office hours currently are Monday through Friday, 8 till 2, and I'll get back to you as soon as I can. Connecting with me through social media, either through Facebook or YouTube, both have the name bslatewahsa. All radio Zoom classes are posted shortly after they're aired on YouTube, and I connect them through my Facebook, so you can find them there as well. So that's a great way to access replays of the videos. And also there are videos explaining common errors and confusing concepts through on YouTube. So that can be another resource if you're struggling with concepts. Math is a very visual subject. And so if you can connect to the Zoom classes through the either live with me here or YouTube, I strongly encourage that. Just listening to it, I'm sure will be really, really challenging to understand everything that I'm talking about. So being able to connect with the videos will set you up for the most success. If you don't have access to the internet, but you do have access to a computer, you can let me know and we can put all of the recordings onto a USB key and send them out to you. So just let me know if you need that. Are in week 2, our last day, day 8. And today we're having our first Throwback Thursday. We're going to review lessons 1 through 5. So you might be asking, why are we reviewing already? We're only in our 2nd week. There has been a great deal of research done, particularly by Herman Ebbinghaus from 1885 is when his research started, about forgetting information that you learn. So he has developed this concept of the forgetting curve, which compares retention of new material to the number of days after you learn that material. And if you're looking at the graph, you can see that we quickly lose information, particularly right at the beginning. As soon as we learn something, we lose retention, we forget it fairly quickly, and then over time that retention slows down, that loss of retention slows down, but we've already just over 7 days have lost 60%. We're down to 40% of remembering what we learned 7 days prior. So if you think of how often the experience of that you have to, like, if you cram for a test and then a week later you don't remember anything, or when you come to the exam and you're like, did we even learn this? This is part of the forgetting curve, in terms of that it's very common to forget information if you don't revisit it. So further research has been done that if you revisit that information, not only are you remembering it because you're revisiting it more frequently, that curve slows down. You don't forget things as fast. It takes longer for things to be forgotten. So we're going to be revisiting, we're going to be spiraling through our content and revisiting things so that at the end of our course, when it's time to do your exam, hopefully things will be more fresh in your mind and you'll be more confident with these concepts because we've frequently revisited them and they're not 2 months prior that and we've never talked about them again. All right, so before we dive into checking out what we've done in the past 2 weeks, let's activate our brain and do some mental math. We all remember, I'm sure, Mad Minutes or have heard of them, but what many of us experienced in elementary school, to memorize our facts and to drill them into our brains. And most of us did not find that to be super useful. Pretty much either you knew them or you didn't, and doing Mad Minutes didn't help you to know them better. So instead of going with that sort of framework, we are engaging strategies and utilizing tools that help us to do arithmetic and to be comfortable with numbers instead of just memorizing them. So today's example is 35 plus 29. And for this, we're going to use a concept of compensation. So I can see that 29, if I just add 1 to 29, that's 30, and that's a friendlier number. And so if I add 1 to shift my 29 to 30, I'm going to subtract 1 from my other number because I'm compensating for that. I want to increase my 29 by 1, so I'm going to decrease my 35 by 1, so that gives me 34. And then it's much simpler in my mind to add 34 plus 30, which gives me 64, then adding 35 to 29, which is going to give me 64 as well, because I've just shifted I've added 1 to one side, and therefore I've subtracted 1 from the other side in order to keep the amount overall the same. I've just sort of compensated that information to make my life a little bit easier. It's another strategy for addition. You can do this with more than 1. You could do it with any other number, friendly or not. You do with numbers that make sense for you and make your life easier. Okay, let's recap what we have done over the past 2 weeks. We've covered lots. So lesson 1 was transformations of quadratic functions. Lesson 2 was polynomials and factoring. Lesson 3 was solving and graphing quadratic equations. Lesson 4 was exponent laws. And lesson 5 was simple exponential equations. So that's a lot that we've covered in the past 2 weeks. So we're going to go over some highlights and then the support questions. So I'm going to recap the most important parts of each of those 5 lessons, and then we're going to do a few of the support questions. We won't have time to do all the support questions, but we're going to do a few from each of the lessons. So these are the support questions that are in your IL booklets. All right, so lesson 1, the highlights. So this is transformations of quadratic equations. So remembering that this is looking at the equation and the graph of a quadratic of a parabola and trying to understand what's going on. So A, in our general form, y equals a times x minus h all squared plus k. A represents the opening of the parabola. So if a is greater than 0, if it's positive, then the parabola opens up. And if a is less than 0, if it's negative, then the parabola opens down. H is the horizontal shift. So in y equals a times x minus h squared plus k, if h is positive, if it's greater than 0, the parabola shifts to the right. And if h is negative, the parabola shifts to the left. And k is your vertical shift in y equals a times x minus h all squared plus k. If k is greater than 0, the parabola shifts up, and if k is less than 0, then the parabola shifts down. All right, so let's look at some support questions. These are on page 7, 9, and 10 in your IL booklet. So I have taken the questions and sort of stretched them together because the equations are repeated. And so instead of starting over and over again, we're going to answer multiple questions at the same time. It'll make sense as we go. So for 1, state each of the following for the equation. State the a value and whether the parabola will open up or down. State h value and describing the shifting of the function, and state the k value and describe the shifting of the function. So in your booklet, these questions are separated, that you do the a only, then h, then the k, and I'm just going to combine them so that we can look at the equation once and find all 3 parts. So question 1a, y equals 3 times x minus 1 all squared plus 2. So we are looking for the a, h, and k value. It doesn't matter which order you do this in. You can pick whichever one. It doesn't matter if you do k first, a first, or h first, whatever makes the most sense for you. So a is equal to the coefficient before the x minus h part. So that in this case is positive 3. Because it's positive, it means that we are opening up. H, in our equation, we have x minus 1, which means that h is plus 1. Remember, h is the opposite from the sign that is in the equation. And so this means that we are shifting right. K is equal to plus 2, our coefficient at the end. Because it is positive, we are shifting up. And that's what it is for that equation. Okay, in your IL booklet for number 2 and number 3, question B, there's an error in it. It should say y equals negative x plus 3 all squared. I believe yours says x minus 3. And so it should be y equals negative x plus 3 squared. And then your answers in the back of the book will line up. So here, a equals negative 1. You have a negative in front of the bracket. So that's invisible 1. Because it's negative, we're opening down. H is equal to, we have in our equation, we have x plus 3, which means that h is negative 3 because the sign is opposite. So because it is negative, we are shifting to the right, sorry, to the left. 6. And then K equals, there's nothing here. So so K equals 0 because there's no value. And so then there's no shift up or down. It stays in where it is. Okay, question C, y equals x squared plus 5. So A is equal to 1. There's no value, therefore we have that invisible 1, which means it's positive. So we open up. H, here the x squared means that we're not adding something before we're squaring x, it's just x. So that means that H is equal to 0. So there's no shift left or right. And then K is equal to plus 5, constant at the end. So therefore we are shifting right. We're shifting up because it is positive. Sorry, my brain's a little bit off today. All right, D, y equals negative x squared is our equation. So A equals negative 1. So we open down. H equals 0. So no change. And K equals 0. No change because we're not adding or subtracting anything. All right, E is also wrong in your IL book for number 2 and number 3. It should be y equals negative 1 times x plus 2 all squared plus 1. So make sure that you make that correction and then your answers will line up with the ones in the back of the book. So here A is equal to negative 1, so it opens down. H is equal to negative 2 because in the equation it says x plus 2. This is where you need to be paying attention to where the errors are. Because it is negative, we are shifting left. And K is equal to plus 1. Because it's positive, we are shifting up. Finally, Fy equals 3 times x minus 4 all squared minus 2. So A is equal to positive 3. H is equal to positive 4 because it's x minus 4. Therefore, we need to change the sign. And K is equal to negative 2. Sorry, I forgot the other part. You need to remember both these parts. So A is positive, so it opens up. H is positive, so it shifts right. And K is negative, so it shifts down. That's how we find our values. So then we're going to graph, we're going to do one question where we graph y equals x plus 4 all squared. So we're going to graph, first we're just going to graph our parent function. That's what the question asks. It says graph y equals x squared with each of the functions given below. So we're going to graph our parent function. We know that it goes through 0, 0, and then 1, 1, 2, 4, 3, 9, and then 4, 16 is off of my graph. And then negative 1, 1, negative 2, 4, negative 3, 9, and again, negative 4 would be 16, which is off my graph. So you can use a table of values or just your knowledge of squares to find those points. Make our curve as best we can. Okay, so then this example is y equals x plus 4. So that means that we're going to think about our A, H, and K values are. So A equals 1, so it opens up. H equals negative 4, so it shifts left. K equals 0, so there's no change. So that means that for each of my values, I'm going to shift them over to the left 4 points. 1, 2, 3, 4. So you can do it from each point, or you can, once you have your vertex, then you can then look and think of, well, where are your values going to be in relation to that vertex? So then you draw your parabola. And it's not beautiful, but you get the idea. And as always, it's important to label your graphs so that I know that you know which one is your parent function and which one is your new graph. And that's how we do that. All right, there are more examples. We're not going to go through all of them because we want to make sure we touch all of the topics. So I'm going to jump to a bonus one where we combine multiple ones. So if you're struggling with this, then let me know, we can work together. But here we're going to graph y equals x squared as our parent function with the function below, which is y equals negative times x plus 4 squared minus 5. In your support questions, they sort of break them up separately, and I wanted to do one where they were all together, where we had all components. So first, graphing our parent function. So that we know where we're starting. Breaking apart our A, H, and K. So for our question, y equals negative times x plus 4 all squared minus 5. So A equals negative 1, H equals negative 4, and K equals negative 5. So that means that we are opening down, shifting left, shifting down. So shifting left 4 units. So 1, 2, 3, 4. And then shifting down 5 units. 1, 2, 3, 4, 5. So this is our new point where our vertex is going to be. Then because we are opening down instead of up, we're going to move our other points the same way that they're going to be shifting in the opposite direction. We're shifting down. And let's draw our sketch. So sometimes your parabola is going to cut off. It's not going to look exactly the same size because depending on where you place your grid, and that's fine. So then label our graph, y equals negative x plus 5 all squared minus 5. And then you can see how that has shifted. Okay, so that's what was lesson 1. Now we're going to look at the lesson 2 highlights. So polynomials and factoring. So with this, we expanded using the distributive law, multiplying each term inside the brackets by the term outside the brackets. We also did the expanding and simplifying binomials using the distributive law. We did this through Algebra Tiles, the box method, and you could use FOIL as well. And then we factored quadratic relations where we common factored if it's possible. We found all factor pairs of the constant term, so what numbers multiplied to be the constant term, and we identified which factor pairs then added up to the coefficient of the middle term, so what numbers added to be that middle term. Okay, so let's do some examples. This is on page 11 of your IL book. We're going to look at question 1b. So here this says that is asked to simplify each polynomial using the distributive law. So B says 5x times negative 3x minus 7. So here you could do the box method. Again, all the methods are all fine. Let's think of sort of what we're multiplying. So 5x times negative 3x is going to be negative 15x squared. And then 5x times negative 7 is going to be negative 35x. We don't have any common like terms, so we can't add anything further. So that is all that we can do. That's how we can simplify. All right, now we're going to look at question 1e. negative 6x times negative x plus 2. So again, negative 6 times negative 6x times negative x is going to be positive 6x squared. And if you're needing to do a refresher of multiplying your rules with negatives and positives, I have an integer video that I'll link in the show notes. And then negative 6x times positive 2 is negative 12x. Again, we don't have any like terms, so then we're just finished. That's all we need to do. All right, now we're going to look at question number 2 on page 13. This says expand and simplify each expression. So we're looking at 2a, and this is x plus 3 times x minus 4. So here, because we have two binomials, I'm going to use the box method. It's the one that is works best for me. So we have x plus 3 times x minus 4, and we're just organizing our information in a box. So we have x times x is x squared, x times positive 3 is positive 3x, negative 4 times x is negative 4x, and negative 4 times positive 3 is negative 12. So then we take our terms from in our side of our box and put that equal, write that all out. So we have x squared plus 3x minus 4x minus 12, and that equals x squared. We have no other like terms, plus 3x minus 4x is going to be minus 1x. So we just say minus x, and then minus 12, there's no like terms. So then we've expanded as far as we can go, and we simplified it. That's all we can do. All right, now looking at another example, question 2c, negative t minus 5 times t plus 2. So again, I'm going to draw out algebra tiles this time just to do something different. So we have t minus 5. So you can see with my tiles, even with my tiles, I'm ending up to write them because I don't have actual tiles in front of me. And then times t plus 2. So then to multiply those together, so negative t times t is going to be negative t squared. Negative t times 2 is going to be negative 2t. Negative 5 times t is going to be negative 5t. As you can see, if you're drawing it out, this does not need to be perfect. There's no way that, by no means are my drawings perfect at all. And that is fine. So that gives us negative 5t. And negative 5 times positive 2 gives us probably should have changed colors to have my negatives and my positives. Sorry about that, but that's what it is. Okay, so then our combining all of our terms, we have negative t squared minus 2t minus 5t minus 10. So combining like terms, negative t squared is the only one we have. Then we can see that we have 1, 2, 3, 4, 5, 6, 7, 7t, and minus 10. And there we go. Okay, so we now have 2g is what we're going to do next, which is 4n minus 2 all squared. So this one looks different because it doesn't look like I have two binomials, but remember that 2 means that I have the same thing twice. So I have 4n minus 2 times 4n minus 2. And that's what it looks like when we have a binomial. When we have a squared, we have two of the same thing. So then I'm going to put that in my box. 4n minus 2 times 4n minus 2. So 4n times 4n is 16n squared. 4n times -2 is -8n. -2 times 4n is -8n. And -2 times -2 is +4. So then combining our terms, we have 16n squared minus 8n minus 8n plus 4. So that's equal to 16n squared minus 16n plus 4. There we go. All right, I'm wanting to move on. So there are more questions to expand. So if you are having trouble with expanding those, especially when you have a monomial and two binomials, let me know and we can work through those together. Some examples, but I just don't think that we're going to have time to go through everything. Unfortunately, time flies by. Okay, so we're going to factor now question number 6 on page 14. So asking us to factor completely. So this, we remember that we are looking for, so our question for 6b is x squared plus 2x minus 15. So we're looking for two numbers that multiply to be -15 and add to be 2. So we're going to list our factor pairs. We have, so what sets of numbers multiply to be -15? So we have 1 and -15, -15. We have 3 and -5. We have -3 and 5. And then we want to think about what of these sets add up to be 2. So I can see that -3 and 5 add up to be 2. So those are going to be my factor pairs. So usually in previous examples, we wrote out our binomials and put in our x terms first. I jumped to the times to what our factor pairs were looking for. It's fine, you can do either way. It's sort of how you're thinking about things opposed to the steps that you're taking. So then we end up with x minus 3 times x plus 5. And then we factored it completely. A lot of for factoring, sort of it goes, the thinking happens separately. And then the actual question is just one line. Okay, then we're going to jump to question 6i. 3b squared minus 24b plus 45 is equal to, so we wanted to check to see if we can common factor first. In the first question, I didn't even check just because I knew that it was the x squared had a coefficient of 1. So I wasn't going to common factor from that. So we can common factor 3 out of this. So I have 3 times b squared. And then I need to think about 3 times what gives me -24. So I'm going to say -8b, the middle term. And then 3 times what gives me plus 45. So then plus 15. So I've common factored out, and now I'm going to be looking at my smaller numbers to figure out what times to be something and what adds to be something. So what times to be 15 and adds to be -8. So my factor pairs, I didn't do this on purpose, but we're now multiplying to be 15, whereas last time we did -15. But anyway, 1 and 15 and -15. 3 and 5 and -3 and -5 are our pairs. Then to add to be -8, well, -3 and -5 added together are going to be -8. So we have 3b minus 3 times, 3 times b minus 3 times b minus 5 is our factoring fully. Okay, so that's a quick review of factoring, of expanding and factoring. Now we're going to move on to the lesson 3 highlights. So this is where we're solving and graphing quadratic equations. So solving quadratic equations with factoring, our first step was to know that solving a quadratic equation means finding the x values that make y equal to 0. And step 2 is factoring, meaning finding the terms that multiply to be our product. So then the other part of that lesson was recognizing the zeros on a graph, which is the x-intercepts, so that those looking at a graph, we can see that the zeros are defined as the x-intercepts. So we're going to get to do some more factoring practice, which is why we didn't do a ton before. So question 1 on page 18, factor each expression, then find the roots of each equation. So A, x squared plus 7x minus 30 equals 0. So this is already set to 0, so we don't need to set it to 0, but we need to then factor our trinomial to find out what our two binomials are that then can help us figure out which one of those has to be equal to 0. So we think of what times to be negative 30 and what then adds, what two numbers then add to be plus 7. So our factor pairs of negative 30 are 1 and negative 30, negative 1 and 30, 2 and negative 15, negative 2 and 15, and then 3 and negative 10, and negative 3 and 10. So then which set of those adds up to be positive 7? So negative 3 plus 10 is going to be positive 7. It isn't always the last one, it just says how that's ended up the last few times. So factoring x squared plus 7x minus 30 is going to give us x minus 3 times x plus 10, all equals 0. So we remember that in order for this whole thing to equal to 0, either one of our sets of binomial has to equal 0. So either x minus 3 equals 0 or x plus 10 equals 0. So the only time that x minus 3 equals 0 is when x is equal to 3. And the only time that x plus 10 equals 0 is when x equals negative 10. So our zeros are 3 and negative 10. All right, so now we're going to look at question 2 on page 18. Solve each equation, it says. So A is 42 equals y squared minus y. So this time it's not set equal to 0, so we need to rearrange our equation so that it ends up equal to 0. So here I have y squared minus y on one side of my equation and 42 on the other. So what I'm going to do is I'm going to subtract 42 from both sides of my equation in order to get one side equal to 0. If I do it on one side, I have to do the other side to keep it balanced. So then I end up with 0 equals 42 minus y minus 42. Sorry, 0 equals y squared minus y minus 42. Today's really not my day. All right, so now I have a trinomial set equal to 0. So then I can factor that to figure out what values of y will make this true. So looking, and we say what two numbers multiply to be negative 42 and what two numbers add to be negative 1, because we have that coefficient of 1 here. So instead of going through all of my factor pairs of 42, I'm going to think, well, I need two numbers that are really close together because they end up adding up to be negative 1. So I know that two of my factors of 42 are 6 and negative 7, and negative 6 and positive 7. So instead of listing all of them, I'm just going to look at these two because I think these two are going to help me. So you can do that. You don't have to list all your factor pairs. So 6 minus 7 is going to give me negative 1. So my factor pairs are 6 and negative 7. So then 0 equals y plus 6 times y minus 7. Therefore, y plus 6 has to equal 0, or y minus 7 has to equal 0. Y plus 6 only equals 0 when y equals negative 6, and y minus 7 only equals 0 when y equals positive 7. And so there are our zeros. We've solved the equation. This equation is true. 42 minus y squared minus y is true when either y is negative 6 or y is positive 7. Okay, we're going to look at the word problem on page 4, question 4 on page 19. The person jumps off a 20-meter high cliff into water below. The height of the person above the ground at time t seconds is given by the equation h equals minus t squared plus 30. How long does it take the person to reach the halfway mark to the water? So with word problems, I like to draw myself a sketch whether or not the question asks for it to just help me understand what's going on. So I have a person who is jumping off of a height. As you can see, my diagrams are beautiful. So jumping off of a height, that height is at 20 meters. And there's water below. And that is all the information that we're given from the graph. We're comparing time to height. And our equation is height equals -5t squared plus 30. So then the question asks, how long does it take for the person to reach the halfway mark to the water? So that person is going to hit the water. They're wondering how long does it take to get to halfway between the top of the cliff and the water? So halfway from 20 meters to the water is going to be at 0 meters. So that is going to be 10 meters. So then how we figure that out, because we don't have any other values, is that we say, okay, well, we know this question is asking is if h equals 10, what does t equal? So we can put 10 into our equation. So 10 equals -5t squared plus 30. And we're going to solve for t. So to do this, we're going to rearrange our equation so that we have a factor. So we're going to have 10 take away 10 equals -5 squared plus 30 take away 10. So we have 0 equals -5t squared plus 20. So then we can common factor -5 out. So we have t squared, minus 4. So now we know that either, we can't factor any further. So we know that either 0 equals -5. Well, that doesn't make any sense. So that's not useful. Or t squared minus 4 equals 0. Well, t squared minus 4 equals 0 is only true when t squared equals 4. And t squared, so what number times itself twice equals 4 happens when t is equal to either +2 or -2. You could take the square root of this. You could do this in slightly different steps, but this is following along with what we have been doing. So time can either be 2 seconds or -2 seconds. Well, -2 seconds doesn't make any sense. So it has to be +2 seconds. So therefore, the person reaches the halfway mark at 2 seconds. Here we go. We want to write a sentence that we are interpreting. We know that we've answered the question that was being asked. Okay, so lesson 4, these were the exponent laws. So remembering that we're talking about the same base. So the multiplying power rules, we add the exponents. So x to the power a times x to the exponent b is equal to x to the exponent a plus b. We're dividing powers. We subtract the exponents. So bx over by is equal to bx minus y. And the power of a power rule, we multiply the exponents. So t to the exponent n all to the exponent p is equal to t to the exponent n times p. And we also have the 0 exponent law, which is anything with an exponent of 0 equals 1. So t to the exponent 0 equals 1. And the negative exponent rule is when a negative exponent is equal to the reciprocal of the base. So 1 over the base. So a to the exponent -b is equal to 1 over a to the b. Or if you have a fraction, x over y all to the exponent -z is equal to y over x all to the exponent z. What questions are asking for when we have these sorts of questions. So evaluate means to have a final answer of a number, and simplify just means to combine your exponents as much as possible and not have negative exponents. So we'll do a few of these quickly. -11 to the exponent 0 is equal to 1. B squared is equal to 25. question C, sorry, this is 1C on page 24. 1 over 1 to the exponent -1 is 1 over 81. And D, 15,432 to the exponent 0 is equal to 1. So again, these you can either, the rules, or you can put them into your calculator to find them. To continue on to the simplifying question. So question 2 on page 24. 2 over 5 all to the exponent 6 times, 2 over 5 all to the exponent -6 times 2 over 5 all to the exponent -3. This looks confusing, but remember we have the same base. So this is just saying 2 over 5 is our base. So then we have -6, because we are multiplying, we are adding our exponents, plus -3. So we have 2 over 5 to the -9. And then because we have a negative exponent, we want a positive, we're going to flip our fraction to be 5 over 2, all to the exponent 9. That we could take one step further to be 5 over 2, 5 to the exponent 9 over 2 to the exponent 9. Yeah, both those work. All right, question 2D, we have 3AB squared times C all squared. So we need to remember that we're doing a product of a product. Power of a power means that we apply that power to each of our numbers and variables. So we have 3 squared, A squared, B, we have 2 times 2 because it already was squared, and then C squared. All of our other ones had an exponent of 1, so they were simple. So we have 3 squared, A squared, B to the 4th, C squared. Okay, and now we're going to look at 2F because it is very, very complicated. There's lots going on here. So question 2F is 7m squared n to the 5th, -5th all squared, times -3m to the 4th n to the 8th, all divided by 3mn times -m to the exponent -2 times n to the -4th. So this looks totally confusing, which is understandable. So we're going to break it into parts. First, we're going to do power of a power. It's kind of like order operations. We're going to do the exponent that we have first. So we need to remember that that's 7 squared m. Then we have 2 times 2 because it's power of a power, multiply our exponents. So m to the 4th. And then n, we have a -5 times 2 because it's power of a power, so -10. We're going to leave because nothing else has changed in any of those. We were just simplifying our first part. So I'm just writing out the rest. Okay, so now we're going to, because the top two are multiplying each other and the bottom two are multiplying by each other, we're going to combine those. So 7 squared, 7 squared, we can simplify to be 49 because 7 squared is 49. And then times -3. 4 to the 4th from our first, plus 4 from the second, and n -10 plus 8 from the second, all over 3 times -1, because we have -m, that's a -1. And then we have m1 1 plus -2, and n1 plus -4. Okay, so then 49 times -3 is -147. M4 plus 4 is 8, and -10 plus 8 is -2. All over 3 times -1 is -3. And then m to the 1 plus -2 is -1, and n1 plus -4 is -3. I believe that there's an error in your solutions at this point. So negative 147 divided by negative 3 is going to be positive 49. I believe that it says negative. It needs to be a positive. 8 minus negative 1, right? Because we're dividing, so we're subtracting. And n negative 2 minus negative 3. So we have 49 m to the 9th, n to the negative 2 minus 3. This minus negative 3 is 1, so we just have it. There we go. All right, last few minutes to look at lesson 5 highlights. So this is solving exponential equations. So this was y equals abx, where b is the base of any positive number except for 1, and a is a scalar, any non-zero number. When b is greater than 1, this is exponential growth. When b is between 0 and 1, this is exponential decay. When a is equal to 1, all exponential graphs will go through 0, 1, because b to the exponent 0 is equal to 1. And there's no x-intercept ever. Y never equals 0 in an exponential function. So question 1 on page 29, which expressions represent exponential functions? Explain. A, y equals x squared is not exponential because it doesn't have a variable in the exponent. B, b equals 4 to the t. This is exponential because the variable is in the exponent. And C, y equals 1.05 to the exponent. X is exponential because the variable is in the exponent. Question 2, for both y equals 5 to the x and y equals 1 over 5 to the x, make a table of values. So we're going to do a table of values quickly for y equals 5x, 5 to the exponent x. So when x is equal to negative 2, y is equal to 1 over 25. When x is equal to 1, y is equal to 1 over 5. When x is equal to 0, y is equal to 0. Sorry, y is equal to 1. When x is equal to positive 1, y is equal to 5. And when x is equal to positive 2, y is equal to 25. For the equation y equals 1 over 5 to the exponent x, our table of values, x and y. So when x is equal to negative 2, y is equal to 25. When x is equal to negative 1, y is equal to 5. When x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 1 over 5. And when x is equal to 2, y is equal to 1 over 25. So for B, how are the values in the tables related? We can see the values are the same, but in opposite. They're reflections of each other. So in y equals x to the 5th, our negative values give us our smaller values and our positive values gives us our higher values, whereas in y equals 1 over 5 to the x, our negative values gives us our higher values and our positive values give us our lower values. So graphing both those functions, so y equals 5 to the x, we know that that's going to be exponential growth. I'm just drawing a sketch because we're running out of time. And y equals 1 over 5 to the x, we are having decay. So we know it's going to look something like that. And how are the graphs related? Again, they are mirror reflections of each other. Okay, so we have finished Unit 1. That was a very quick review of a recap of what we did for Unit 1. So you can now submit your lessons 1 through 5 for marking if you want. It's best if you can actually submit them as either as you go, if you finish 1 and want to submit that, or and then 2, finish 2 and then submit that. Or if you want to do all of Unit 1, please submit all of Unit 1. If you wait until all of them are finished, it's going to be really challenging for me to mark and get them back to you. And if you're making mistakes, it's better for me to check them as you go. So as always, if you have questions, please feel to contact me. Thanks so much for joining me today. Have a lovely day and a lovely weekend. Miigwech.